Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 354, I chat with Darin Fong about his out-of-your-head headphone virtualization software. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CacheFly.com.
This is Home Theater Geeks with Scott Wilkinson, recorded May 18th, 2017. Episode 354, Going Out of Your Head. Hey there, Scott Wilkinson here, the Home Theater Geek and editor of avsforum.com. This week's guest geek is Darin Fong, owner of Darin Fong Audio, developers of Out of Your Head, which we're going to be talking about today. Hey, Darin, welcome to the show.
Hey, how you doing, Scott? Good to be here. Thanks for having me on.
My pleasure. Thank you for being here. Those of you who are tuned in live at live.twit.tv can join the chat room from there or at irc.twit.tv. And you can post questions for Darin as we go, and I'll pass along as many as I can. It always helps if you put my screen name in your message, anywhere in your message. That's my name, Scott Wilkinson, all smushed together, no dots or dashes or anything like that. So, Darin, what we're talking about today is what's often called headphone virtualization.
Right.
So tell us sort of what that is and what are some of the foundational elements that we need to be concerned about.
Well, basically, when you talk about virtualization, the idea is to recreate sound sources that are outside of your head. So the idea is that obviously we all hear in 3D out in the real world. And so what our software does is it recreates the experience of listening to speakers in a room, but while you're wearing your headphones. So I guess you could say what our software does is it recreates the sound waves that would be hitting your eardrums if you were sitting in that room listening to those speakers. So, but, virtualization in general is just the idea of recreating sound that's localized in 3D space versus what you hear just with regular headphones where the sound is all inside your head for the most part, between your ears.
Right. Now, we talked about this 2 weeks ago on the show when we spoke with Rauschik Kausik about the OSIC 3D headphones, and we talked about head-related transfer functions, or HRTFs, and these are pretty critical in the whole situation, aren't they?
Yeah, absolutely. So just to recap a little bit, the way that our brain has learned as we grow up to localize sound, to figure out where sound is coming from, is we learn as we grow that when we hear a sound over here, that's where the sound is coming from. So the idea, though, is that the sound comes in, bounces off the pinna of your ear, your outer ear. It also bounces off surfaces and reflects, and all of that is for you is your HRTF, your head-related transfer function. That encompasses the size of your head, the shape of your ears, all the little nooks and crannies in your pinna, the outer part of your ear,
which are as unique as fingerprints, as we learned a couple weeks ago.
Yeah, absolutely. So everybody's ears are different. It also can incorporate, to some extent, your torso and really everything around your ears that then kind of defines how you hear sound.
Mm-hmm. And so if you're making a virtualization system such as yours, which has the wonderful name Out of Your Head,
right.
I just love that. You need to take that into account. You need to have that be part of the system so that, because that's really the only way to replicate or virtualize hearing sounds outside your head.
Right. So the way we do it is our system is based on measurements. So we will go into rooms and measure different rooms with different speakers, and then we don't use a dummy head so much. We use real people's heads, and yes, everybody has a different HRTF, so it's not perfect. And I'm the first to admit that, yeah, it's not going to match perfectly, but for most people, it matches close enough that you still get the sense of the speakers out in the room, and it's accurate enough so you can even tell how big the room was, if there were any reflective surfaces in the room, or even what brand of speakers they were, where the speakers were in the room. All of those things are recreated basically based on our measurements.
And so you actually go out into different rooms that have different speakers in them, and you take measurements using your own head with microphones in the ears, or somebody else's head?
Right. So we'll vary. It depends on who I have available to use their heads. I'll use my head, certainly. And so our measurements are done with different people's heads. So sometimes people will find a better match with some of our different presets. But yes, we identify either vendors or mostly private homes where they'll let us come in and do the measurements. So if they have a really amazing speaker system, or $1 million listening system, then we'll go in and measure that. So that way, when you use our software, you can hear your audio as if you were sitting in their listening room.
Well, that's pretty cool. And in fact, we have a list of the presets that you have already created, and there are 29 of them here. Is that still the number you have, or have you added to some?
Yeah, no, that's the current list for sure. And we're always looking for places that will let us come in and do the measurements. But yeah, we've traveled all over the place, measuring all these different speakers in different rooms. Right.
I mean, we have the acoustic Zen crescendos, and you've put the prices of some of these speakers on them, which I think is kind of cool. 16 grand, the Magico Q3s, which are wonderful speakers. Those are 39 grand a pair. Let's see, what's the most expensive ones here? The acapellas.
I think that's number 20. Number 28, I think, is...
oh, man, the Martin Coltrane Supreme 2 for almost $500,000 a pair.
Yeah, and that's just the speakers. So, obviously, whoever the owner of those has equally as expensive amplifiers, preamps, cables, everything to go along with it.
Mm-hmm. And I see you've also got a few rooms here as well. The Genelec recording studio, the AIX recording studio, Mark Waldrop's room.
Yep.
Yeah. Does that include speakers in those particular speakers in those rooms as well?
Right. Yeah. Like with Mark's place at AIX Studio, that's his whole setup, his calibrated, THX certified, everything, the speakers, the whole system, basically.
With B&W, I think he's got B&W speakers in there, as I recall.
Right. He has two different setups for 7.1 versus 5.1, or last time I was there, which was a while ago. But yeah, he has a JBL set and then B&Ws. I think the B&Ws are for 5.1 and the JBLs are 7.1. I may not. I don't remember exactly that.
Yeah, that's all right. That's all right. So here's a question that just occurred to me. Would it be possible, I guess you'd have to have the speakers in the room. I was thinking about whether or not you could model a room and then model a pair of speakers, and so that you could put different speakers into a given room, virtually speaking.
Yeah, unfortunately, we don't do things like that just because we try and keep the accuracy based on real measurements of actual rooms and actual speakers. So we're not using a computer algorithm to synthesize the reflections or the effects. We're playing back the actual acoustic measurement of the room. So yeah, unfortunately, we don't even have the capability of moving the speakers or changing the acoustics of the room. I mean, we can a little bit, but the reality of it is that we try and keep it as accurate as possible based on the room measurements.
So what then are your goals for this project? I mean, what do you want people to be able to do with it or experience with it?
Well, you know, when I developed it, it was really out of necessity in that I always, growing up, my father was an audiophile, and we always had really nice stereo systems. And when I got older, I bought really, you know, big Mark Levinson cello system. But once I had kids, I never had a place to set it all up. I couldn't stick, you know, speakers out in the middle of the room or set up a whole home theater system. And so, you know, I listened to headphones, but it never really gave me the same experience that I always loved listening to speakers. And so I wanted to come up with a way to have the best of both worlds, give that speaker listening experience, yet at the same time have the privacy and the convenience of using headphones. And so now I can watch a movie, and you know, a big action movie at full volume at 1 a.m, and I'm not going to disturb anybody. And so, but even for 2-channel audio, you know, when you're listening to a symphony or a band, and to hear that soundstage out in front of you, where what speakers do, and that includes all the imaging. To me, that's a much more realistic experience, as opposed to listening to headphones. So really the goal is just to again, get the best of both worlds, to have the privacy and convenience of headphones. You can just listen to it on a laptop and yet still hear a speaker system, and not just any speaker system, but some uber expensive speaker systems that
you'd never be able to afford otherwise.
Anyway, yeah. So
right. Another application I can think of is like a recording engineer who has a studio, right? And their speakers and their studio setup. But what if they go on vacation or they're on remote or something, and they want to be able to mix in their own studio? This would allow them to do that.
Right, absolutely. In fact, we have gone to work with recording engineers and gone into their studios, and we'll do the measurements not with our head, but with that recording engineer's head. So the HRTF perfectly matches their ears. And then once we do the measurement, then using out-of-your-head software, they can then mix using their headphones, but it sounds just like they're sitting in their studio. So if they're on location, if they're in a hotel room, or they're traveling and they want to do a rough mix of what they just recorded, there's a lot of applications where they can have their studio sound, but portable or mobile.
Got a couple questions in the chat room. I Am Special is asking, surely one speaker in each earpiece can't reproduce the 3D effect? And the answer is no.
Well, yeah, the idea is that we listen to the
not without processing, not without this some sort of processing.
No, without processing, no, you can't. But yeah, the idea is that we're recreating the sound waves that would be arriving at your ears if you were listening to those speakers in that room. So I
guess this has been made possible in part because of the processing power that's now available in laptops and so on.
Yeah, definitely. I mean, this virtualization of sound has been around for a long time. I mean, Dolby had Dolby headphone out years and years ago, was probably one of the early or the most popular early technologies. It's still around.
It is, yeah.
But back then, yeah, the amount of processing power you had available was so tiny that it's amazing that it worked at all. I mean, but yeah, these days now with the amount of power that's in a typical, computer, it's a lot easier to do, much higher quality too.
Right. Good Sound is asking, does facial hair make a difference in the HRTF model?
I don't know, to be honest with you, how much that makes a difference.
There is some diffusion, I think, in the beard, right?
Yeah, you'd think a little bit, but by the time I think when you were talking to the guy from OSIC, he had talked about how the nose shape didn't really have that much influence either. So I think by the time the sound is reflecting off, your chin or something like that, maybe not that much of that is getting back into your ear canal.
Let's see. Emily the Strange had a question here. Wait, shouldn't you be using the customer's own head so it caters to them? Well, you can do that. I mean, it's somebody who wants to hire you to take the measurements with their own head could do that, right?
Yeah. So in an ideal world, absolutely, you would do your own measurements for your own ears. But in the real world, that's really not practical most of the time. But we can do it. It does require that the customer or the listener is physically in the room with the speakers. And then I'm there too to do the measurements with our microphones using their ears. And we have done that. I've had people fly in from all over the world to where we are in San Diego. I've also gone to other people's homes or across the country and do custom measurements. In that case, then the accuracy is extremely high.
Right. SoCal Ray Jr. in the chat room is pointing out that Ivan, one of our AVS forum members, his theater was one of the rooms you used for your presets.
Right. Yeah. He was nice enough to let me come in, and he has a great home theater setup. And so, yeah, that home theater setup is his.
Yeah. UJ in the chat room is asking, what source material do you play when you take your measurements?
Oh, it's just test signals. Yeah. We're not playing
like white
any music,
noise, pink noise, that kind of thing.
Yeah, right. Or frequency sweeps, your typical measurement when you're measuring anything, headphones, speakers, things like that.
Yeah, it's funny. A number of people in the chat room are talking about how expensive those speakers are, which is really one of the main points we're trying to get at here is, you could spend $500,000 on a pair of speakers or 100,000 or whatever they are. But if you get a system such as yours, you could experience a great deal, a great large fraction of what they do without spending that kind of money.
Yeah, well, it's interesting because, when you talk about the cost of state-of-the-art, top-of-the-line headphones, that's a small fraction of what you're talking about in terms of dollars when you're talking about these speaker systems. So the performance you get out of even modestly priced headphones is pretty amazing compared to what it would cost to get a similar performance out of speakers. So I often use the analogy, it's kind of like a motorcycle versus a car. Like you can get a motorcycle for relatively little money that's as fast as a Ferrari.
Right.
So that's kind of that's what's kind of cool about it too, is that even with $200 or $300 headphones, you can hear quite a bit. You can really hear the differences in all these speakers.
Now the system basically runs on a computer, right? It's a software system, and the audio has to come from within the computer, right? That's how the system is how it works.
Right. So in order for us to process the audio, we do require that audio originates from the computer. Now, it works for streaming and things like that. So the media itself doesn't have to be on the computer, but yes, in order for the audio for us to process the audio, it has to be playing through a computer. We are working on supporting mobile devices, but currently we require Windows or Mac computer. But it is all software based. There's no it works with any headphones or any amp, any DAC. You don't need any specialized hardware.
And we have a couple graphics to show here for that. The signal path I wanted to show people. Tell us, run us through this.
Yeah, so basically you start off with your media player app, usually, whether you're streaming or you're playing it locally or playing it through a server. Some examples I use are like JRiver Media Center, VLC, iTunes, Netflix, etc. So your audio or video or both is sourced from your media player, and then you just our software then installs as a virtual audio device. It's a driver to the operating system. It looks like you have a sound card installed. The operating system knows it accepts up to 7.1 channels. So then it sends the audio from the media player to out of your head. Out of your head does its processing. It's essentially real-time binaural processing. So it converts everything down to the left and right ear. And so once out of your head is done with it, it sends it out as a 2-channel audio signal that then runs out to your DAC or built-in audio of your laptop or computer. And then from there, it goes to your amplifier and then to your headphones. So that bottom row signal path is just your normal headphone signal path.
Sure.
The only difference is up at the top where out of your head takes the multi-channel or 2 to 8-channel audio and makes it into a binaural 2-channel signal.
Mm-hmm. And that's the part of the key right there is the word binaural. We talked 2 weeks ago about binaural recordings and how when you make a binaural recording, you put a pair of microphones in your ears or in a dummy head's ears and record sound on those headphones, and that automatically imbues the recording with the head-related transfer function of the person wearing those microphones. And you're doing the same thing when you're measuring something. You're putting microphones in their ears and doing the same thing. So in essence, as you say, the out-of-your-head software is creating a binaural audio file. I guess it isn't exactly synthesizing it. It sort of is. It's based on a real measurement, not a synthesized computer-generated HRTF, but it's still,
right.
It's applying that to the sound file, the audio data that's coming in, right?
Right. Yeah, exactly. And so it's basically recreating it. It takes the incoming audio and says, okay, based on this measurement, if that sound was coming out of that speaker, how would it reflect around the room, around your ears, and then arrive at the ear canal? And then we play back or essentially create what that sound would be if you were playing your music on those speakers. Yeah, but it is, it's like a real-time, you can almost call it just a function that transforms the audio into what you would hear if you were sitting in that room.
Mm-hmm. Speaking of real-time, that introduces a question. Probably doesn't really matter, but what kind of latency does the software introduce?
Right.
I mean, how much delay is there between what it gets and what it puts out?
Right. So we spent a lot of time optimizing our algorithm and our code to try and get the latency as low as possible. The main reason is that, when you're listening to just music, then it doesn't really matter. But when you're talking about movies or streaming movies, and mainly gaming. So for gaming, you can't have much of a delay. Right now, on most computers, it averages around 30 to 60 millisecond delay, which is still not in the realm of like professional gamers that want it down to like 1 or 2 milliseconds. But certainly for lip sync in a streaming video, or for most gamers, that's within, acceptable limits. Yeah, we'd love to get it down even further, but we're doing a considerable amount of processing on that signal.
Yeah, no kidding. I said it doesn't really matter, and I was only thinking about pure audio, music.
Right.
But whereas we're watching a movie or playing a game, that becomes extremely important.
Right.
Is there any way to maybe delay the video?
You can,
so that it syncs up?
Right. So for most media players like JRiver or VLC, there is a video sync or audio sync setting where you can, essentially delay the video by, you can adjust it by the millisecond.
Right. So you make it 30 or 60 milliseconds, whatever the software is delaying by, and you achieve lip sync again.
Right. And even some of the streaming players like Netflix used to have a audio sync adjustment. I'm not 100% sure if they still have that in there, but it was in there to be able to adjust for sync. And then, of course, for gaming, you can't really do that because
I was going to say, yes, movies so we have levels of acceptability for delay. Music only, who cares? Doesn't matter.
Right.
Movies, you want the lip sync to be in place, but that's information flowing in one direction only. Right. Gaming is another thing where you're doing stuff and responding to stuff, and if that's delayed on the screen, that could really mess you up.
Oh yeah, some gamers, hardcore gamers, have told me, if 30 milliseconds is an eternity. Like I'll die if I don't hear that person behind me with the gun, in 5 milliseconds or less, then I'll get shot.
I'm toast.
I'm just like, wow, what's your reaction time? I mean, 5 milliseconds.
I know. I mean, human reaction time is typically, like in the 200 millisecond range.
Right.
So I can't understand why a 5 millisecond delay would make a difference, but perhaps it does. There are experiments I've seen where actually the response time of the brain is actually less than the conscious response time, right? So they do experiments where they say push a button when you see something on the screen. And they flash something on the screen, the person pushes the button, and it's maybe 200 milliseconds delay. But when they're measuring the brain activity, it's much less than that.
Yeah, maybe they're just got super ninja reflexes. And
well, there's that too. Yeah, right. Yeah. Barfel in the chat room has a good idea. It says maybe doing something like this on a Raspberry Pi, which is this, tiny little computer that a lot of people use for media. Have you ever thought about that? I think that's running Linux or some form of Unix or something. I'm not real familiar with Raspberry Pi, but
yeah, definitely.
Seems like a good idea because like a $30, $50 computer or something, and portable, totally portable.
Yeah, no, a lot of people use those for their media center, PC basically. And yeah, given enough processor, you have your options of what kind of processor you put in those, and running Linux, it could definitely be used as your source. I mean, a lot of people use it as a source, and then I have to say we don't have a Linux version of Out of Your Head currently, but it's something we could definitely do, and we have actually looked into running it on a smaller piece of hardware. Yeah,
well, certainly, as you say, you're working on the portable devices, iOS, Android,
right?
But there are some problems inherent with that you need to overcome, right?
Oh yeah, we've been working on it for a long time. The biggest issue is that you're not allowed to, hook the audio from another app. So everything is what they call sandbox, meaning every app stands alone. And so, if you want to process music files, then your program has to be a media player as well, because that's the only way you can get the audio signal. So then you have to be a video player, an audio player, and people want their playlists and their libraries. And so you have to build all of that just to be able to process the audio.
I Am Special is asking, I understand right to left sound, but what about front to back? How is that reproduced?
Right. So again, going back to just as our brains are being trained as we grow up and hear sounds, you would think that there's no way to tell whether a sound is in front of you, dead center in front of you, like 10 feet out, or 5 feet in front of you, or in between your ears, because the sound would be arriving at both ears equally. But there's enough of a difference that your brain can distinguish where that sound is front to back, as well as left and right. Now, I will tell you that front to back localization is the most difficult thing to reproduce. Left and right and anything off angle isn't too bad, but
right.
It has
and the reason,
to be
and
really
the reason
good.
I should make sure everybody understands, the reason is that there's a difference in the time of arrival, that the sound, if a sound is off on an angle to your right, the sound will reach your right ear before it reaches your left ear. And that's very tiny time difference, but the brain is exquisitely attuned to it. Similarly, there'll be a level difference. The right ear, it'll be a little louder than it will be in the left ear. So those two things right there make it relatively easy. But as you say, if you're straight on the money, that's pretty hard.
It's really hard. In fact, even with our software, when you listen to, we have a speaker test where it just plays a woman's voice from each of the speakers. The front center one is the one that's toughest for most people to hear. So I know I've had people who have tested out our software, and when they do hear front and center out in front of them, then they know that they're like, wow, okay, this really works. And I'm not saying that that's going to work the same for everybody because of the differing HRTFs, but for a good percentage of the population, they're able to hear in our software that front and center channel.
And in fact, we have that little clip that I would like to play people now, which is called, I forget what you called it, channel check or
channel ID or something.
Channel ID, something like that. Now, to be clear, you and I, Darin, will not hear this because Skype audio is mono. But anybody else listening live to the podcast or after the fact, if you're listening on headphones, you should be able to hear the effect because it has been encoded with the out-of-your-head software into this binaural signal.
Right. So this recording is just a recording of the output of out-of-your-head software. We created this 7.1 test file, and so what you'll hear, as long as you're wearing headphones, is the output from out-of-your-head.
All right, let's check it out.
This is the out-of-your-head channel identification test. This is the left speaker. This is the center speaker. This is the right speaker. This is the right surround speaker. This is the right rear surround speaker. This is the left rear surround speaker. This is the left surround speaker. The next sound you will hear is the LFE speaker.
Leave now while you still can.
I love that at the end. And what I really like about that particular video clip is that it shows you which speaker the sound is coming from. Which gives you a visual cue, which probably enhances the sense of this, the sound is coming from this speaker or that speaker.
Yeah, I mean, I created those visualizations for that reason, of course, to see the amplitude and the frequency of the sound coming from those speakers. What I can tell you is that for most people, the visual cues can really help with hearing the sound where it's supposed to be. So I encourage people to sit in a room the first time they listen to Out of Your Head, sit in a room with some actual speakers. They don't even have to be hooked up. It's just your brain sees speakers and thinks, oh, the sound could be coming from those. I even tell people just put cardboard boxes out in the room and your brain will believe that, well, the sound is coming from over there, so it must be coming from that cardboard box. Mm-hmm. Other times I'll have people, sitting in their cubicle or at their desk, and they'll listen to it, but then have difficulty because the sound is coming from the other side of the wall in front of them. And then their brain says, well, that can't be happening. So therefore the sound can't be over there. And your brain sometimes collapses the image because it doesn't believe that the sound could be coming from the other side of the wall. Right.
So there's a whole synergy of visual and audio that come together here. There was a great question here. UJ asked, when you're virtualizing a room and a pair of speakers in a room, does the user undergo any odd effects when they move their head?
All right. So yeah, that brings us into the topic of head tracking. So we don't have head tracking. Being a software-only product, we don't have a hardware head tracker. But what I've found is that you're correct in that when you turn your head, then the image of the speakers or the location of the speakers will also move with you. And that's certainly not like real life. So the idea with a head tracker is that when you turn your head, it would shift the image the opposite direction to then keep speaker image in one place. As it would
appear as though in the room you have a pair of speakers over here and you move your head, they don't move.
Right. So that's the idea behind head tracking. And I have used head trackers and they definitely work. But generally when people are watching a movie or gaming or even listening to music, they're not turning their head that much. And yeah, some will argue that the micro movements of your head, just tiny movements, is enough to kind of compromise the image of the speakers. Personally, I just think that even those people I know that use systems with head trackers, including myself before I came up with Out of Your Head, I never ended up using the head trackers after a while. Initially, it did help for your brain to hear what that imaging and get used to it. But ultimately, it was not really necessary. And so I find that once you get used to it, even if I turn my head a tiny bit, I still find that your brain pretty much says, well, that sound is coming from over there. So it must be over there. In the future, honestly, I didn't think that the implementation of head tracking was worth the amount of effort it would require to, build hardware, sell hardware, et cetera.
Yeah, that's a whole nother can of worms, isn't it?
Yeah, I mean, you can do it with a camera and face tracking. Certainly, Snapchat and all that, they do head tracking as well. So you can do it that way. But again, I just felt that concentrating on other aspects of the audio processing would be more beneficial than the head tracking. Yeah.
Got a couple of comments in the chat room about that last clip, and we're going to play another couple of clips. One, Fight Till Death says, really works. I Am Special, though, said, must be me, but all I can hear is left to right.
Interesting.
And Jack said, it almost seemed to work through Twitch, you know, through the live streaming that we're doing here. White Noise said, oops, I had my headset on backwards. That could have been kind of weird.
There is a lot of information in those audio cues for your brain to figure it out. And so, the fidelity of the stream and your bandwidth and things like that, if you're not getting all the little micro details of the reflections in the room, then that can compromise the effectiveness of the sound. But generally, it works even with low quality sound. But all the clips that we're playing are available on our website for you to watch. And
this was Barfel's question. Is that clip available online? The answer is yes.
So we have a whole online demo page on our website, and also there's we posted it on YouTube. But then you can just on any device put your headphones on, and the quality should be pretty good. Even streaming it straight off our website.
Yeah, let's take a listen to another clip. Actually, the one called "Presets On Off." And this one, I think, is a 2-channel setup, if I'm not mistaken.
Right. Yeah, it's just 2-channel music.
2-channel music, and the effect, the out of your head effect, is going to be turned on and off, so you can hear the difference. Let's take a listen.
Go ahead.
Yeah, man. It's got some great comments in there. A Stretch 1931 says, wow, big, significant difference. It's like the difference between black and white and color.
Yeah, so that demo also went through some of the different speaker presets, so you could hear the different rooms and the different sound. And so that's what the second half of that demo was.
To hear different speakers.
Right.
And then finally, one last clip I want to play is Pink Floyd's Money in 5.1, which is one of my favorite 5.1 music mixes of all time, the whole Dark Side of the Moon. But here's a little clip of Money. Yeah. And again, you and I can't hear it right now because we're on Skype audio, but hopefully those of you out there in the audience can really hear that. So the next question that I really wanted to talk about was immersive audio. Out of your head at the moment is 7.1. The maximum that it can accept into its processing, 8 channels.
Right.
But of course, these days we have immersive audio. We have Dolby Atmos, DTSX, Auro 3D, which put speakers over your head. How much harder is that to do even than what you're already doing?
Yeah, really, it's not any harder per se, in that when we do the measurement, it doesn't matter where the speakers are. So if we were in a room where there were overhead speakers and we measured each of those, then that would by default localize the sound from those channels from above or wherever they were in the room when we measured them. And then it's just a matter of expanding our processor to process more than 8 channels. We could really scale up to as many channels as we had computing power. I would think certainly 12 to 16 channels shouldn't be a problem with most modern, computers. So that is something that we plan on doing. The one issue at this point is that we do require that the media player be able to decode or render that immersive audio. So in the case of a Blu-ray that has Atmos or DTS:X, you would need a player app that could decode and render Atmos and then deliver it as more than 8 channels to our to out of your head software.
Ooh, so that's tough. That's tough because the Atmos renderer basically decodes Atmos into whatever number of channels are in the system. Right. It has already identified how many speakers you have, whether it's 5.1.2 or 7.1.4 or whatever. The renderer knows that ahead of time. Right. So that makes it pretty tough. I wonder, which leads to the question, could the app accept, say, the Atmos bit stream and decode it itself? That would require a licensing fee to Dolby, no doubt, but I suppose it would be possible.
Yeah, that would be one way to handle it. To be honest with you, we're a small enough company that the licensing fees are pretty prohibitive. Those licensing fees are designed for large volume, obviously huge companies. And so the costs are really prohibitive. And that's why we don't even decode Dolby HD or DTS. We don't decode any of that. We rely on the media player apps to decode it and send it to us as discrete channels.
So I guess you would need a Blu-ray player app from somebody else that would decode to a preset configuration, like 7.4.1, for example. Right. And so you're basically taking streams of PCM data, of decompressed, uncompressed, decoded, I should say, audio, and some number of audio streams. And at the moment, you're limited to 8 just by the software. But if the computer has enough processing power, you could increase that.
Yeah. No, we could expand certainly to support. Yeah.
But are there any apps that currently do the decoding of immersive audio and output those audio streams? I don't know.
I don't believe there are, and in fact, I just thought about it now. I don't even know what kind of processing power is involved in doing that, because now with Atmos decoders or DTS decoders, those are generally all done in hardware on the AV receivers or some type of hardware. So
right, exactly right.
Yeah, I don't know how much computing power you'd need in order to do it in software.
Stretch 1931 is asking, does the system work with any operating system? And I think we already mentioned that it's OS X and Windows at this point. Are you you're maybe looking at Linux or Chrome OS even?
Yeah, Linux wouldn't be too big of a stretch. OS X is kind of loosely based on Linux. So we could do Linux. We just, our resources are limited and we just haven't had enough of a demand. But But in looking at devices like we spoke about earlier, like Raspberry Pis and other smaller devices that don't run Windows or OS X, then yeah, we may do something in the future.
Speaking of the software, I wanted to show pictures of the user interface for OS X, Mac, and Windows, just to show people kind of what they would be looking at. Let's take a look at either one of those, doesn't matter which. This is the Mac interface, I guess. Tell us what we're looking at here.
Yeah, so basically you have on the left side are the input channels, and there's audio meters that will show you if you're getting any audio on those channels. So you can see if your source is your media player app is in fact decoding and feeding you the right number of channels.
And can you change the level of those input channels?
Right. So you can adjust the level of all of the input channels, and the levels are saved for each preset. So that way you can adjust them for the different speakers. In the middle column are the speaker presets. So those are all the different rooms, that list that we saw earlier. That's how you select a different room and different speakers, just by clicking on those presets. And then on the right is your output devices. So that's telling out of your head, where do you want me to send the 2-channel processed audio? So if you have additional, a USB DAC or external DACs, then that will show up in that list. And then you can select that to wherever your headphones are connected.
By the way, I hope you'll forgive me. The editor in me looks at that list of presets and sees the word magical speakers. I suspect you mean Magico, right?
Yeah, so that's actually a throwback from early on, and I never changed it. But early on,
sorry, I can't help it.
No, it's fine. It's actually a funny story. I didn't really want to include the actual speakers that we measured, but eventually I was just like, this is silly. I'll just leave the real names in there.
Oh, I see. You were trying to make kind of fake names that were like the name of the actual speakers.
Right.
All right.
So far, I haven't had any issues with the speaker manufacturers, but so
right, exactly. Let's see. Oh, I was going to ask you about different types of headphones. How do different types of headphones affect the experience? Like in-ear monitors versus on-ear versus over-ear, open back versus closed back, planar magnetic versus dynamic, or whatever. Have you done much research into that?
Yeah, I have a lot of headphones.
I bet you do.
Part of that, my excuse is that, I got to test them, right? So I got to buy headphones. So that's my excuse, and I'm sticking to it. But yeah, the headphones definitely change the sound, obviously. So yeah, a brighter pair of headphones is going to sound brighter, and more detail or less detailed, more bass, less bass. All of that stuff certainly affects the overall sound. But it does seem like, because there's so much involved in these audio cues and the micro detail of all the little reflections, the tiny phase shifts, the little reflections around your outer ear, being able to reproduce those little details can help with the overall effect. And so kind of like, you think of the faster or the more responsive, the headphone driver can sometimes help. So I find that electrostatic headphones, because the membranes are so thin and they can really render some of that micro detail, that they do work really well. But that's not to say that other types of headphones don't either. And a lot of it comes down to personal preference. I figure if you own those headphones and that's what you listen to, then you must like the sound of those headphones. Therefore, that whatever effect it has on the sound, that's what you like. And you can, we don't have EQ. We don't try and make every headphone sound the same with EQ. You do have the option of using any EQ plugins or things like that on your media players if you want to EQ your headphones, but we don't do that internally. And, one could argue back and forth whether or not that's even possible, is to EQ headphones to sound the same.
I would think not, because HRTFs are dynamic.
Yeah.
I mean, they're static in that your head doesn't change, but
right.
The sound coming from different directions that would cause essentially what you're doing is EQing and delaying and so on. But that would, I can't imagine that a static EQ could possibly achieve the same effect.
One interesting thing about different headphones, though, is that because out of your head does give you such a wide, open sound stage, is that even with closed back headphones or in-ear monitors that typically sound pretty closed in, with out of your head, it just opens up the imaging, to several feet or out in front of you rather than, inside your head. So it's really interesting when you're listening to closed headphones, but to hear such an open sound from it. And then some people have told me that having open headphones helps the effect as well, because it's that much more open sounding. I think it does make a difference in that, again, it goes back to your brain. When you can hear sound from the outside, even with your headphones on, then your brain can believe that you're hearing sound from sound sources outside.
Good point.
Even with your headphones on. And so I think that's part of it, is that you're like, oh yeah, that's believable. Whereas with closed back or in-ear monitors, it can be less believable. And all these things factor into it. Some people say, well, with in-ear monitors, I don't feel the headphones sitting on my head or things clamped around my ears. So I do believe that the sound is coming from out there because I don't have things sitting on my ears or on my head. So all these little things can definitely change your perception of what you're hearing.
UJ is saying, I'm sure a plugin could be made for FooBar. Have you worked with FooBar at all? I haven't much. It's a Windows program.
Yeah, no, I'm very familiar with FooBar. Part of the reason why we didn't go with a plugin architecture per se is we wanted something a little more universal. So when you're using an app that doesn't support plugins, you can still use out of your head. You can use out of your head with FooBar. You just in FooBar, you just tell FooBar to output to the out of your head sound card, and then we take it from there. So you can utilize your FooBar's playback chain with your DSPs or whatever you like to use, and then still feed that into out of your head without the need for a plugin.
UJ also asks, have you done any collaborations or consultations with Tyle Hertzens? He's the editor-in-chief of Inner Fidelity. Been on this show many times, and really a great, really knowledgeable headphone guy.
Oh yeah, I know Tyle. I see him at all the shows. I've met him many times. He's done a couple of spots on the Inner Fidelity website. We haven't really talked about collaborations per se at length, other than hopefully someday maybe he would review it. But other than that,
yeah, well, that would be a good thing.
Yeah, other than that,
I got you.
No, he's great.
Got you. UJ just followed up. He said he meant a FooBar plugin to handle the channelization to feed out of your head. Does FooBar decode Atmos? I would think that would be the application we might be thinking about here.
Right. No, I don't know. I'm not aware of any plugin that will decode Atmos. FooBar, I believe, does have plugins for just about everything. So there's plugins that decode multi-channel audio formats. And there are other plugins that will do channel up conversion. So something that we don't do is we won't take, say, a 2-channel music source and then convert it to 7.1.
But you won't up mix, in other words.
Right, but you can do that within FooBar or JRiver or any of the software that supports plugins. They can convert, say, a 2.0 music file and convert it to 7.1, and then feed that to Out of Your Head, so you'll hear the up converted 7.1 process.
Right. iPhone 95161, who I believe is Hamid, is asking, have you tried this with blind people? And I believe he is sight impaired, to see if on a Mac it works with VoiceOver, and on a PC if it works with screen readers. I don't quite know what that means. Do you know what he's talking about?
I'm not familiar with the software. Honestly, I don't know if any visually impaired people are using Out of Your Head. I haven't come across any. I have talked to a few people with that are hearing impaired, specifically some who have hearing loss in one ear. And what's interesting about it is that what they can do is turn the level up on that one ear, and it's hard to explain, but it's kind of like turning up the level of what you hear. So it's not just turning up the level of the left speaker per se, or it's turning up the level of what's being fed in the sound
into your left ear. Yeah, I see. That's interesting, and I do see the distinction.
Right. So the idea is that they're able to listen to music and speakers as if their hearing was more, wasn't imbalanced like that.
As if they had a hearing aid in one ear.
Right. In
a sense. Yeah. Wow. Not screen readers, screen readers.
Okay.
He mistyped there, and I didn't catch the mistake, so I apologize for that.
Yeah, what's interesting is that because our Out of Your Head installs as a virtual sound card for the operating system, all sound, if you set it as your default output device, all sound on your computer will be played back through Out of Your Head. So system beeps will beep out in front of you. And so virtually anything that's playing audio on your computer can be routed through Out of Your Head.
So last question, what are your plans for the future? And we've talked about mobile devices, and that has some problems that you've described, and immersive audio, that has some problems. What else might you be thinking about? I mean, obviously don't want to give away any trade secrets here, but
I mean, in an ideal world, I've really thought about having a component of the software that allows you to do your own measurements. But again, that gets into sourcing hardware and selling hardware. But the idea would be we would provide we'd sell you a pair of microphones that you could then make your own measurements with your own HRTF, giving you a much more accurate representation of the speaker system. But
that would also involve what you would get as a measurement is not only your HRTF, but the particular speakers you were listening to in the particular room you were sitting in. Right. So
that's tricky too, because what people ask me all the time about, well, what if I can make my own measurements? And I always say, yeah, that'd be great. I'd love to be able to do that, but you have to remember, you have to actually go do those measurements somewhere. So I can tell you from experience that it's tricky to find places to go to do these measurements. Typically, the audio stores, the stereo stores don't really like you to.
They don't want you to come in, listen to their $100,000 speakers in their beautiful room, in some cases, take measurements, and then walk away and say, thanks, I don't need your speakers anymore.
Right. So you can see immediately why that, and speaker manufacturers too, are difficult to get time with them. And so it's not easy. I mean, I've been working for the last, 4 years or so, compiling these measurements from all over the place. And I think that's the first realization that people come to when they say, oh, great, I can, I'll go do my own measurements. And then you start asking around, and it's, it's hard.
Yeah. I guess the best application I can think of for that would be if you have a great system that you really love, to do your own measurements of it, so that, as we talked about earlier, when you're traveling, you can still have the experience of that great system in your hotel or on the airplane or whatever.
Yeah, absolutely. So yeah, the thought of being able to take your home system and take it to your office and listen to it there, or take it on a plane. Yeah, I mean, I'll sit there on a plane watching a movie and listening on a, $100,000 surround stereo system, speaker system. I'd always tell people I feel guilty that no one else can hear this. Shouldn't be possible. It shouldn't be possible on an airplane to hear sound like that.
Yeah. Well, listen, thank you so much for being here. It's been a fascinating conversation, and best of luck with Out of Your Head.
Yeah, thank you so much. I really appreciate being on the show. And if you go to our website, you can download free trial. You can hear the demos that we played earlier. So all of that's there.
Lots of good stuff there. Yeah, absolutely. And that, by the way, is FongAudio.com. So be sure to go check it out. Darin Fong, thank you so much.
Yeah, thanks, Scott.
All right. You can find me always at avsforum.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott and at avsforum. You can always find previous episodes of Home Theater Geeks right here at twit.tv/htg and on our YouTube channel, youtube.com/twit-home-theater-geeks. Next week, I am working on a special surprise. It's not 100% yet, but it's getting there. And if it happens, it's going to be pretty cool. And I'm not going to tell you about it now. I'm going to let you wait and expect something really interesting next week on Home Theater Geeks. So I do hope you will join me. Until then, geek out.